Hello, everybody. So let us discuss the second um, branch of calculus called integration. Okay, now what is integration? So basically, integration is nothing but the opposite of differentiation. All right, and integration, there are two parts. One is called the definite integration. Okay, and the second part is called indefinite integration. All right, now in this chapter in your syllabus, your class 11 level, we are going to use a lot of definite integration. Okay, very rarely we will use indefinite integration. In fact, we don't use indefinite integration at all. So therefore, I will discuss only definite integration. All right, so let us see what is this integration all about. The integration of a function f(x) is written as, in fact, this is the definite integration. Let us be a bit precise out here. It is the definite integration of a function f(x) is written as, you have this sign out here. This sign is called the integral sign or the integration sign, and then you put some numbers below the integration sign. You have a number a, and above the integration sign on top you have a number b, f(x) dx. So when we have this, it means that this part, the dx part, it means that the function is integrated with respect to x. Okay, you can have y dy. If it is dy, then in that case it is integration with respect to y. You can have dt, then integration with respect to time, so on and so forth. Now what are a and b? A here is called the lower limit and b is called the upper limit. All right, so when we go into when we work out, when we give the examples, when we do the examples of the integration, you will come to know how to set the values of a and b. Okay, so for now you just know that a is the lower limit and b is the upper limit. All right, now this sign here, like I told you, it is called the integral sign or the integration sign. Now basically you see that this looks like the letter S, a very slender S, right? And why? Because integration and summation are basically the same. All right, so S, summation starting with S, so that is why we have this sign here. Okay, so it's basically the same. They work on the same way. Okay, all right, now for integration we have one theorem, and this is the only theorem that we are going to use. Okay, and this is called the theorem for definite integration. All right, so let's say you have integration from a to b, from lower limit a to upper limit b of a function x to the power n dx with respect to x. Okay, so it comes like this. Now this power x will increase by 1. You remember or not, in differentiation what happened? The power will decrease by 1, right? So I told you that integration is opposite to differentiation, so now the power will increase by 1 divided by this new power, and then you put this inside of the square bracket. Now the limits of integration will come from behind the square bracket. Okay, now this second step is important. Now what we do in the second step, instead of this x, we first put the upper limit. That means this whole thing here, instead of x, we put b. So therefore, instead of x to the power minus 1 divided by n plus 1, we get b to the power n plus 1 divided by n plus 1. Then we put a minus sign, and then again, instead of x, we put the lower limit. Okay, so you have a to the power n plus 1 divided by n plus 1. So this theorem is valid for all values of n except n is equal to minus 1. Okay, you cannot do this. You cannot apply this for n is equal to minus 1. All right. Okay, let us do some examples. For example, let's say example number 1, integration from 1 to 2 of let's say x to the power, let's take the smallest one, x squared dx. Okay, x squared dx. Now what do we do here? This x squared, the power here is 2. So if we apply this theorem, the power will increase by 1. So therefore now it will be x to the power 3 divided by this new power 3, right? And this will go inside of the square bracket. Mind you, this is not dimensional analysis, okay? It's just a square bracket. And these limits now will go from behind 1, 2 like this, okay? And then next, what do? You first put the upper limit instead of x. So I will have 2 to the power 3 by 3. Then minus, now I put the lower limit instead of x. So I have 1 to the power 3 by 3. Okay, so 2 to the power 3 here is 8. 8 by 3 minus 1 by 3. So basically here the LCM is 3. So we have 8 minus 1 on top on the numerator. So this will be 7 by 3. That is the answer. All right, so that is the first example. Let me give you more examples. Take a new page, number 2. How about let's say okay, x to the power, let's say integration from minus this lower limit, it can be minus 1 to plus 1 of let's say 3x x cube. Okay, 3x cube dx. All right, so what we do here now, this 3 it is a constant, right? So I can take this constant out of the integration sign. So you have 3. Then basically I'm just integrating from minus 1 to plus 1 of x cube dx. Okay, and this will, let me write down here. So that will be 3. Now this power of x will increase. It will increase by 1 step. So that will be x to the power 4 divided by 4. Okay, and the limit will go from behind of the square bracket. So you have 3, and then what do we do now? We put the upper limit first instead of x. So you have plus 1 to the power 4 divided by 4 minus 1 to the power 4 divided by 4. This goes, we have to put a bracket out here. Okay, so basically anything 1 to the power 4 is 1 only. So this will be 1 by 4 minus to the power of an even number. So that'll be plus. So that'll be 1 by 4, right? So this 1 by 4 minus 1 by 4, you get it to be 0. Okay, so that's the second example. Let's go to the third example. What shall I take? Shall I take yeah, let us take, let's say from 2 to 3, let's say from 2 to 3 of let's say 5 by x squared dx. Okay, 5 by x squared dx. Now what I do here, this 5, which is a constant, always a constant, you can take it out of the integration sign. All right, so this is 2 by 3, and then this x to the power 2, you never put it in the denominator. Okay, so what you do here, you take it up into the numerator. So you're taking it up, you get x to the power minus 2 dx. Right, so you have 5 here. Now you can apply the theorem. So this power of x now will increase by 1, isn't it? So you have x to the power minus 2 plus 1. Okay, and minus 2 plus 1 is minus 1. All right, so let me not let me cut short a little bit. So this will be minus 1 divided by what? Divided by this new power. Okay, minus 1. Okay, put this inside of a square bracket, and where from the limits will come from behind, from 2 3, then you have 5 5. Then what I can do here, this minus 1, I can take it out, because anything divided by 1 is itself only. So only the minus sign, I can put it outside. Then basically you have x to the power minus 1. This x to the power minus 1, I can write it as 1 by x. Yes, from 2 to 3. And then you have minus 5. Now I can replace the limits. First of all, the upper limit. So you have 1 by 3 minus, now the lower limit, 1 by 2. Okay, so you have minus 5, then minus 1 by 3. So we have to take the LCM. So LCM here is 6. 6 divided by 3 is 2, so you have 2 minus 6 divided by 2 is 3. You have 3 here, so let me put it somewhere here. So you have minus 5, so 2 minus 3 is minus 1 by 6. So basically this is 5 by 6. So that is the answer. Okay. Okay, so let us do one more integration. Not one more, let us do a few more integrations. What number was that? This was number 3, so let us go to number 4. And in gravitation chapter you will see this integration, okay, from, let's say, from r to infinity, g m capital M by x squared dx. Okay, so here what is g, m and m? G here is obviously the gravitational constant, which is a constant, and small m and capital M, these are the masses, and we know that masses are constant, so this whole thing can be treated as a constant. In fact, they are constants. Okay, so these are what? These are constants. So what do we do with the constant? We take it out of the integration sign. Okay, we do not integrate a constant. So you have g m m, this will go out of the integration sign, and then r to infinity, and this x square is in the denominator. I have to take it up, right? So you have x to the power minus 2 dx. Okay, so I have g m m. Now I can apply the theorem. X to the power minus 2, what will happen to this power? This power now will become minus 2 plus 1. The power will increase, okay? And minus 2 plus 1 is minus 1, divided by this new power, minus 1, not by minus 2, okay? Please be very careful out here, all right, when you apply this second step. R to infinity. All right, now what do we do with this minus sign? Just like previously, we take the minus sign outside, so I can take this g m m, and then this x to the power minus 1, I can write it as 1 by x. Okay, it's more convenient to write it first to 1 by x, r to infinity. Okay, so you have minus g m m, and then this x here, now we can replace the x with the upper limit first of all. All right, so first of all, so instead of x, I will have 1 by infinity, and then minus, then we replace x with the lower limit, 1 by r. Okay, and do you know what is 1 by infinity? 1 by infinity is 0, right? So you can just neglect this part. So therefore inside the bracket you have minus 1 by r, minus with this minus you get it becomes plus, so you have g m m by r. That is the answer. Okay, so suppose, okay, let us do one thing. Let us just change the limit of integration. All right, let us see what will happen if we change the limit of integration. Let's go to a new page. This is number 5. Now I am going from infinity to r of g m m by x squared dx. So what do you think will happen out here? Okay, just something will happen. All right, so gmm is a constant, I take it out. Then again here from infinity to r, again x, I take it up, so you have x to the power minus 2. Okay, so what do we do now? This will be dx. All right, so you have gmm, and now this will be x to the power minus 1 divided by minus 1. The limit of integration now will go from infinity to r, and minus gmm, right? I'm taking this minus sign in front. Then inside of bracket I have 1 by x from infinity to r, so you have minus gmm. Now I can replace x with the upper limit. Upper limit now is r, so you have 1 by r minus 1 by infinity, right? So this will be 0, so you get minus gmm by r. Okay, so what is changing out here? What difference do you get? You see here, if you change the limit of integration, Only thing will change is the sign. Okay, let us have a look. In number 4, we have gmm by r with a plus sign, and in number 5, we have the same thing with a minus sign. Why does the minus sign comes? Because the limit of integration has changed. Okay, let us do some more. Let's say number 6. Okay, let's say we have an integration from x naught to x of a dx. Okay, so here a is, what is a? A here is constant acceleration, right? Constant acceleration. So it is a constant thing, so obviously we take this constant out and we integrate from x naught to x of dx, right? So you have here what? So basically here this is just 1. Okay, so you have here a, then x. So this is actually what? This is actually x to the power 0, is it not? Yes. So can I write it like this? You don't need to take many steps, but let's just, for the sake of our understanding, here you don't see any x. Okay, you might question how come it's not of the form of the theorem, right? So actually here there is a 1 in front of dx. Okay, there's a 1 here. Okay, and what we can do is we can write it as x to the power 0. Okay, and then here x to the power 0, now it will be what? It will be x to the power 0 plus 1, so that will be x to the power 1 divided by 1, right? Divide by 1, but it looks very odd if you divide by 1, that's understood. Okay, and that will be inside of the square bracket from x naught to x. All right, so here you have a, and then instead of x you put the upper limit, which is x itself, minus, instead of x you put the lower limit, which is x naught. Okay, so this is the answer. Right, number 7. Let's say we have can we do one thing? Let's say we have this integration from u to v of dv. All right, so dv here is the velocity. Okay, so again here you have a 1 out here. All right, so what we can do here, we can just go directly till here. So this is basically v minus u. That is the answer. You can prove this, you can work this out and prove this. All right, so those are the basic integration, and I've covered almost all of the important integration that you're going to use in your in class 11. So please work these integrations nicely and you understand it nicely. All right, because these are going to be very important. We are going to apply these in chapter 3 and also in your gravitation chapter. Okay, thank you.